Okay, got a couple more people confused. That's okay. That's how we learn. So if we do some what I call rough draft thinking, so we're just gonna kind of think, throw things out there of what we see in that problem. Anybody want to throw anything out there that they think would be a good strategy to start with? Especially those of you that said I'm confused. Any thoughts on a good strategy to start with?
You can turn all of them into what? Or two eighths.
Okay,
All
so
the
you're
denominators.
saying we need to come up with some common denominators because we're adding and subtracting. What do y'all think about Jahan's strategy? Is that a good place to start?
Well, maybe before that we could change it to addition.
Okay, another good strategy. Do you all agree with those two strategies? Is that what I should do? Give me a thumbs up if that's what I should do. Okay, all right, so I'm gonna kind of do them together. How about that? Jahan said eighths because we're looking at fourths, eighths, and halves. So our common denominator is eighths. So 1/4 becomes 2/8. Then we're going to do change it to addition. Take the opposite of that number. This is already 3/8, so we're plus 3/8. Change this to addition. Take the opposite of that. So plus negative 1/2 written in eighths is 4/8. Okay. What are we going to do now? What do we think now? Does that make it a little bit
Add
easier?
them together.
Yeah.
Okay, so these are both positive numbers, right? If the signs are the same, we just add them together. So 2/8 and 3/8 makes 5/8 plus negative 4/8. Well,
Is 1/8.
1/8.
Going if we're
It's
going this way 5/8, so I'm going this way, and then this negative sign throws me back this way, but it doesn't take me all the way to 0. It takes me to
1/8.
positive 1/8 because I'm going negative 4/8. Okay, so positive 1/8. So did that help those of you that were a little confused? Did you like their strategies, their rough draft thinking? They came up with, let's make everything have a common denominator, and then let's get rid of all that subtraction because then we can use our number line to help us figure out what the answer is. Okay, those are all strategies that you can use when you get stuck in a problem. All right. All right, what we are going to do today is I am going to do the review with you. We're going to work out all, I think there are 12 problems. We're going to work out all 12 problems for the review for tomorrow's test. Now, if you're not to that in the module, if you haven't done this stuff beforehand, what I want you to do is just do it on paper and pencil, and then when you get to it, you've already got the answers and you can just enter your answers. How do we feel about that? Would that be a good use of reviewing for you so you would do better on tomorrow's test? Yes? Okay, I got a thumbs up from somebody. All right, so if you need to go get paper and pencil, I want you to go get some paper and pencil. All right. Okay. Who needs more time to go get paper and pencil? Okay, I'll wait, Peyton. Those of you that didn't come to morning meeting, in the chat, I am going to put a Google form that you need to complete. This is your progress report. Whoops, I only sent it to, who did I send it to? Jeremiah. I need to send it to everybody. Let's try that again. Everybody in the meeting. This is a quiz grade in all of your core classes. So when you submit it, we will give you a 100 in your core classes. Each class you'll get 100 on a quiz. All right, are we ready? Is that big enough that you can see it?
Yes, good.
It's good? Okay. All right. I would just do it with share screen, but I have difficulty writing on the screen. So we're going to use this and see how it goes. All right. What is the scale factor that takes figure A to figure B? Okay. Give me some strategies. What are we looking for when we're trying to figure out scale factor?
The sides.
The sides. Well, we got a circle. So, and then this is on a diagonal. So that's hard to figure out. So we don't have any sides that we can figure out. So give me another strategy. Love that strategy. Didn't quite work for a circle.
Look at the, this is my strategy.
Okay.
Look at where that little, so you know how it basically looks like a pie that got a piece taken out of it.
Yes, yes.
Look at where the piece would have been taken out of.
Right
Count
here.
how many dots it is from one side to another,
Okay.
and see if the other copy has that many sides.
Okay. So
And then see if the bottom to the top is the same amount of,
6,
and see if the bottom to the top is the same length
3, 4.
as the other one.
Okay.
Okay, and then see that little dot in the center?
Yeah.
Count down to that, to the line. And if both copies have the same number, then it should be a scaled copy.
Well, we're told it is a scaled copy, but you're right. That would be how we could determine it. So this is another distance we could do. This is 1, 2, 3, 4. This would all, let's see what this is. 1, 2, 3, 4.
So the scale
Okay.
copy is 1.
So
and
it
then
is a scaled copy. What
scale
is
factor
the scale factor?
1.
What did we multiply this by to get to that?
1.
1. So this has a scale factor of 1. When something has a scale factor of 1, it is an exact copy. Okay, loved that strategy. You even checked to make sure it was a scale copy. Could we have done that distance as well?
Yes.
We could have picked any, as long as it was corresponding, we could have picked any distance on here and counted it. Okay, and we're picking distances where we can count the units that are on the grid. Questions you have on the first one? Okay. Moving on to the second one. All right, what is the scale factor that takes A to B? Strategy. Kimmy, give me a strategy.
So what I was gonna say is so you see that it kind of looks like that triangle in the middle of the shape. Yeah, right. You can count up.
So this line right here.
Yeah.
Okay.
And that's 3.
Corresponding line over here. So we're finding corresponding points, okay? And then count them. Is that what you said?
Yeah.
1, 2, 3. This one is 1. So how do we get from 3 to 1? What's our multiplier?
1/3.
1/3. So our scale factor is going to be 1/3. What if we picked a different corresponding side? What if I picked that side?
Then
That corresponds here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 1, 2, 3. How do I get from 9 to 3?
1/3.
1/3. So it's kind of a way of checking to make sure we got the right thing, right?
Yes.
All right. Questions you have on that? All right. Can I erase? Anybody need more time? All right, let's try the next one. You can always screenshot these as I do them too. But it'll help you remember if you write things down. All right. Strategy. Throw something out there. Let's see, what do we think? What is the scale factor that takes A to B? Is it going to be greater than 1, less than 1, or equal to 1?
Greater than 1.
Greater than 1 because we're going from small to big. Okay. Do we want to do we need to look at, what do we need to look at?
Maybe we
Find
could use
corresponding distance.
Okay, we could do a corresponding distance. I like that thought. How about this distance right here is 2. The corresponding distance is right here, 1, 2,
4.
4. So how do we get from 2 to 4?
2.
We multiply and get by 2.
Multiply it by 2, so that means our scale factor is 2. What if we
And-
didn't want to do distances? What if we wanted to do sides? Could I pick this side and this side?
Yes.
So that's 1, 2, 3. That's 1, 2, 3, 4, 5, 6. Do I have the same multiplier?
Yes.
Yes. Okay. Thoughts, questions, comments? Who needs more time? All right. All right, it says select all the statements that must be true for any scaled copy Q of polygon P. Now notice Q is not there, is it? But we know
No.
lots of things about scaled copies. Okay. Side lengths are all whole numbers. Do we know that that's must it be true?
I don't think it's true.
Do we even know what these side lengths are?
No.
No. So these could be decimals right now or fractions. And if we multiply it by a fraction or a decimal, we could end up with a fraction or a decimal, right?
Mm-hmm.
Because the scale factor can be any number. All right, so that isn't a must be true. The angle measures are all whole numbers. Well, what do we know about the angles in scale copies?
They're always the same.
They're always the same. So are all of these angles whole numbers?
Yes.
Yes, so our scaled copy is going to have all of them whole numbers. They are in fact going to be those exact angles because otherwise it won't look like the same figure. All right, Q, we don't have a picture of Q. Q has exactly one right angle.
Yes.
Well, how many right angles are in P? There is one. And we just said that the angles in the copy are exactly the same as the angles in the original. So that's going to be a true statement. That has to be true. All right. If the scale factor between P and Q is 1/5, so if I'm going here to Q and we're using a scale factor of 1/5, that means I'm going to do what to all these measurements?
Multiply
Multiply it by
1/5.
1/5, okay? If the scale factor between P and Q is 1/5, then each side length of P is multiplied by 1/5 to get the corresponding Q. Is that a must be true?
Yes.
Yes. Is there anybody else out there but Kimmy? Okay, are we doing good? I don't mind if she answers all of them, but I need to know that you're following along, okay? All right, if the scale factor is 2, each angle in P is multiplied by 2 to get the corresponding angle Q. Is that a true statement? Am I going to take 90 degrees and multiply it by 2 and get 180? Am I
No,
going
ma'am.
to take 135, multiply it by 2 and get 270? Will it still be the same figure if I change the angles?
No.
No, it
No.
won't look the same, right? I mean, this is no longer going to be a right angle. It's going to be a straight line. So it's not going to look the same at all. So the angles stay the same. So we never multiply the angles by the scale factor. All right. Q has 2 acute angles. What are acute angles?
They I don't know how to explain.
Anybody?
Isn't it
A cube is small angle.
Smaller than what?
90-degree angle.
Smaller than 90 degrees. So 2 acute angles. Well, this is acute. This is acute. So will Q have 2 of those? Yes. Okay, I saw somebody shaking their head. Yes.
Yeah.
What are obtuse angles?
they are angles bigger than 90
Okay,
degrees?
so we've got, let's change the color here. We've got 1, 2, 3. So is this a true statement? Yes, it is.
Yes.
Okay. Questions you have for me?
I actually have a question.
Yes, Liam.
Would we classify a right angle as an obtuse angle as well?
No.
Or
A right angle is a right angle. Obtuse is greater than 90, but greater than 90.
okay, then what is the never mind, I got it.
You got it? Okay.
Yeah.
They can be obtuse, acute, or right. All right. Who needs more time? All right. We're moving along. Polygon F has a perimeter of 22 units. Pictures are worth 1,000 words. Let's draw a picture. The perimeter, let's see, this is F. The perimeter equals 22 units. Polygon G is a scaled copy with a factor of 3. So that means it's bigger. Didn't leave myself a whole lot of room here. So to go from here to here, we multiply by 3. So what happens to the perimeter? If I take this side and multiply it by 3, this side multiply it by 3, this side multiply it by 3, this side multiply it by 3, what's going to happen to the perimeter of that?
The perimeter is going to be the perimeter is going to be multiplied by 3.
Perimeter is going to be multiplied by 3. So what is the perimeter of G? 66 units, because 22 times 3 equals 66. And if we go back and think about those notes that we took, when you take the original perimeter, you multiply it by the scale factor to get the copy perimeter. You want me to write that down so you can copy it? Give me a thumbs up if you want me to write that down. Okay, so we're going to take the original perimeter and we are going to multiply it by the scale factor, and that's going to give me the copy perimeter. Not my best handwriting, but can you see that? Original perimeter times the scale factor gives us the copy perimeter. All right, who needs more time? Okay. Polygon S has an area of 12 square units. Well, let's make a square or something, a figure. And the area, this is S, the area equals 12 units squared. Polygon T is a scaled copy with a scale factor of 5. That means it's bigger. And we want to know what is the area of T. Well, if this is 12, that means this side could be 3 and this side could be 4. Is that true?
Yes.
Okay, so now if I'm using a scale factor of 5, I am going to multiply by 5. So this side is going to be 20. This side is going to be 15. So what is the area of T?
300.
300 units squared. How about that? We just answered the question. Now there's a shortcut. We don't have to find the area of them and the side lengths. Do we remember this rule? The original area times the scale factor squared equals the copy area. And it's squared because we multiplied this times 5 and this times 5. So we actually multiplied it by 25.
I wonder, what if, so instead of 3 and 4, will we get the same answer if we used like 6 and 2?
All right, let's try it. Great question. So let's make okay, 6 and 2. All right, 2 times 5 is 10. So that side will be 10. 6 times 5 is 30. 30 times 10 is
300. Oh, so
300. That's why we can say this right here. Original area times scale factor squared equals the copy area. Even if we used 1 and 12, it would still work.
oh,
Okay?
okay.
Great question. All right, who needs more time? Okie doke. Slide this up a little bit so I'm not writing in the
Miss
box.
Lou,
Yeah,
I was late because I thought class started at 9:30.
I'm sorry. We are doing the review, so if you want to get out paper and pencil and write down what we're doing, then you can put it in the Google form on Canvas when we get done. Okay? Because we're reviewing for tomorrow's test. All right. If AE is 4 units, how long is the corresponding distance in the second figure? So we are probably assuming that these are scaled copies of each other. So it probably needed to tell us that. So we have right here is 4. And we want to know the corresponding distance. So that would be that distance right there. Do we know the scale factor?
No.
Well, do we know two sides that correspond already?
Yes.
Okay, this 6 corresponds to that 15, right? Do we agree?
Yes.
Yes, okay. So how do we get from 6 to 15? Oh, I'm gonna make a table. A little bit of a table here.
Maybe
Can
we
I
can divide.
I can divide, but can I just multiply it by 15 over 6?
Yeah.
Because 6 times 15 over 6, the 6's cancel and I'm left with 15. So my multiplier is 15/6. Okay. Now I'm going from 4, and what am I going to multiply it by? 15/6. So take out your calculator. 15/6 times 4. What does that give you?
10.
10. So this one has a length of 10.
What could have also worked is if you multiplied it by 2.5.
No, 6 times 2.5 is not, is
No,
it?
no,
Oh, yeah. Yeah, it is. If you do 15 divided by 6, you get 2.5.
yeah.
So your scale factor is 2.5, which is what 15/6 is. Okay?
So for the answer, is the answer 15 over 6 or 2.5, or does it not matter?
No, what are they asking?
Oh, yeah. Okay, yeah, 10.
How long is the corresponding distance on the second figure? So the answer is 10 units. Questions you have for me? Who needs more time? All right. Rectangle A measures 11 by 5 inches. Rectangle B, so this is A. Rectangle B is a scaled copy of A. Select all the measurement pairs that could be the dimensions of rectangle B. So when it says it's a scaled copy, that should tell you it's going to have a scale factor, and the scale factor is a multiplier, right? Okay, so would it work to have a rectangle that is 5.5 to 2.5? Well, how do we get from 11 to 5.5? Because that's the corresponding side. So how do you make 11 into 5.5?
Divide by 2.
Divide by 2 or multiply by 1/2, okay? So we're going to do the same thing here. So 5 divided by 2, or 5 multiplied by 1/2, is going to be
2.5.
2.5. So did it use the same scale factor? You said divide by 2, and I can live with that. Did it use a scale factor? Yes. So this one is true. All right, 8 inches and 1 inch. So how do we get from 11 to 8? Did we multiply it by 8/11ths?
Oh,
All I'm doing is turning it into, I'm going to multiply this by 11/8. No. Did I do that wrong? Yes, I did. 8/11ths. So if I multiply 11 by 8/11ths, do I get 8? Yes. Okay? Now, if I take 5 and multiply it by 8/11ths, do I get 1? What is 5 times 8/11ths? Is it 1?
No. 8.
Well, 5 times 8 is 40. 40 over 11, is that going to be 1?
No.
No, so that one's not true. Okay, 16.5 and 7.5. So how do I get from 11 to 16.5? Well, I'll take 16.5 and divide it by 11. What do you get? Something times 11 equals 16.5. So the inverse of that is going to be 16.5 divided by 11 is going to give me my something. So take out your calculators and do 16.5 divided by 11. I'll wait for you.
It's 1.5.
1.5, okay? So this has a scale factor of 1.5. What if I take 5, multiply it by that same scale factor, what do I get? 5 times 1.5, what do I get?
7.5.
7.5. So can that be a scaled copy? Yes. All right, how about 15 inches by 9 inches? What did I do? 15, 11, looks like I added 4, 9, 5 to 9, did I add 4? Can we say a scale factor is 4? I added 4 to both sides.
No, you can't.
Troy, why can't I? You shook your head yes at first, or were you just yawning? Can you add for the scale factor? Can we add for the scale factor?
Are you asking everyone?
Everyone, can we add for the scale factor?
No.
No, we do what for scale factor?
Multiply.
Multiply. All right, 11 inches by 5 inches. Is that a scaled copy?
Yes, I would think so because.
Yeah, it's exactly the same, so it has a scale factor of 1. Okay, so those are your 3 answers. Okay, who needs more time? Okay. We have 2 different maps of Havelock. The scale on the first map is the red easy to see on the black, or is there a different color that's easier to see on the black? Is the red working?
Yes.
Okay. All right. The scale on the first map is 1 inch to 5 miles. As soon as I see a scale, I think to myself, draw a table. Okay. So I'm going to do drawing in actual. And if my scale is 1 inch to 5 miles, the distance between Tyler and Diego's house is 3 inches. The scale on the second map is 1 inch to 30 miles. What is the distance between their houses on the second map? And don't forget the unit. So what's the story about? What's this story about? What's the story about?
I guess it's about the distance between Tyler's and Diego's house.
On a map, right? Okay.
Yeah.
All right. So what can we countermeasure? We can count 1 inch and 5 miles. What else can we countermeasure?
1 to 30
Okay,
or
1 to 30 on the second map. And on the first map, it's 3 inches, right? So I'm gonna put 3 inches right there because that's on the map. That's the drawing. So how far is it between Tyler and Diego's house? Well, how do I get from here to here?
you
Multiply by 3. So what am I gonna do? 5. Multiply by 3. So how far is it to their house, between their houses? 15 miles. Now, did I answer the question? What is the distance? What is the distance between their houses on the second map? So it looks like I need to do another table. This time I'm using the scale of 1 inch is 30 miles. Do I know the drawing or do I know the actual?
the drawing.
No, I want to know what is the distance on the
Oh,
drawing.
okay.
Do I know the actual? Didn't I just figure out how far it actually is?
Yes.
Okay, so where am I going to put the 15? Under the 1 or under the 30? Is the 15 the actual or is that the drawing?
This one.
Actual.
Actual. So 15 is going to go right here. So how do I make 30 turn into 15?
Divide it in half.
Divide by 2.
Divide it by 2 or multiply it by 1/2. Okay, if I do it on that side, I have to do it on this side. So how long is it on the map? 1/2 of an inch or 0.5 inches. Either answer works. Okay, questions you have for me? Who needs more time? All right. We're almost done. Min makes a scale copy, a scale drawing of her rectangular garden using a scale of 1 to 25. Her garden measures 5 meters long by 3 meters wide. What will be the dimensions on the what will the dimensions on the drawing be? Note that 1 meter equals 100 centimeters. Change all the meters to centimeters to complete this problem. What's the story about?
A map of her garden.
Okay, a garden. Okay, what can we count or measure? What can we count or measure? We've got a scale of 1 to 25. We've got a garden that measures 5 meters long by 3 meters wide. And we're also told that 1 meter is 100 centimeters. So that's what we can count or measure from the problem. All right, now we need to think about what kind of strategy are we going to use? Well, what are they asking us to find? What will be the dimensions on the drawing, right? That's what they're asking us to find. Give me a strategy. Am I going to use a number line? Am I going to use a table? Am I going to use a drawing? What do you want to use? Throw something out there.
Table.
A table, okay? So we're going to have drawing and actual because we are given a scale. We are given a scale of 1 to 25. Are there any units in that scale?
No.
No. So we have to assume that they are the same unit. Because we are dealing with meters and centimeters, we are going to use centimeters. Okay? So this means 1 centimeter represents 25 centimeters in her garden. So looks like I need to take 5 meters equals how many centimeters? Well, what do we know right here?
1 meter equals 100 centimeters.
So 5 meters is how many centimeters?
500.
500, and that's the actual. All right, what's my multiplier? 25 times what equals 500? 25 times what equals 500? So I can do the inverse of that. 500 divided by 25 equals my what?
1.
20? Okay.
Yes.
So we're going to have 20 centimeters on one side. Well, because this is a multiple choice question, can I stop right there and say this is the answer? Yes, but we're not always going to have multiple choice. So you're going to do this again with the other side. Same scale factor, 1 centimeter to 25 centimeters. But now we're going to be dealing with 3 meters equals how many centimeters?
300.
300. So 25 times something equals 300. So 300 divided by 25 equals that something. So what's our something?
12.
12, okay. So to get from here to here is 12. So now I have to multiply that by 12. So do we get the same? Yes. So that is our answer. 20 centimeters by 12 centimeters. It's going to be what it is on the picture. All right. Questions you have for me? Who needs more time? All right. Almost done. 3 more problems. All right, the scale on a map says that 6 centimeters represents 15 kilometers. What distance on the map in centimeters represents 200 kilometers or 20 kilometers? All right, what's the story about?
It's about a distance on the map.
There you go. Okay. As soon as I see that, I'm thinking, I bet I'm going to use a table. Would that be a great strategy?
Yes.
Okay. What can I countermeasure? Well, I can count that 6 centimeters represents 15 kilometers, and I've got 20 kilometers. Well, I know that's a rate, so I can put that right here. 20 kilometers. What distance on the map in centimeters represents 20 kilometers? So is that 20 kilometers the drawing or the actual?
I think the actual.
Okay, so we need to know 15 times something equals 20. So the inverse of that is 20 divided by 15 equals what? Take out your calculators. 20 divided by 15.
1.3.
And it keeps repeating, right?
Mhm.
So that's 1 1/3. Okay, so our multiplier is 1 1/3. So now we're gonna multiply 6 by 1 and 1/3. So what do we get?
8.
8. 8 what? What's our unit gonna be?
Centimeters?
Good. It's the drawing. It has to be 8 centimeters. All right. Can I erase? Who needs more time? Who has a question?
So in the what is it, the unit 1 review, the survey thing that we're doing, do we actually put 8 cm?
You can.
Okay.
Okay. All right. I'm going to erase. All right. This looks like another similar problem. The scale on a map says 6 centimeters represents 15 kilometers. Heard that a minute ago. So I'm going to do the same thing. The story is about a map and an actual distance. We know 6 centimeters represents 15 kilometers. What is the actual number of kilometers that is represented by 11 centimeters? So 11 is going to go here. So 6 times something equals 11. So the inverse is 11 divided by 6 equals that something. So let's see.
1.83.
1.833333. Is
Yes.
repeating? Okay, I forget what that is. So 11, that's 1 and 5/11. So our multiplier is 1 and 5/11. So now take 15 and multiply it by 1 and 5/11. So if you're on your calculator, all you got to do is just hit times 15.
27.5.
Yep. So our answer is 27.5. And what's our unit going to be?
Kilometers.
Uh-huh. Questions you have for me? Starting to feel a little bit better about this? Tables are wonderful things, aren't they? All right, last question. Slide it up a little bit.
What was it?
27.5. All right. A scale drawing of a park is 5 inches wide by 7 inches long. The actual park is 100 yards wide. What is the area of the actual park in square yards? What's the problem about?
The size of a park.
Okay, the size of a park. What can we count or measure?
The 5 inches to 7 inches and the 100 yards.
Okay, and this is the drawing, is that and that, right? And this is the actual park, right? All right, strategy. What method? Draw a table. Drawing, actual. We're given a scale, 5 inches. No, we're not. Let's try that again. Draw a table. You want to draw a table. Is that going to help us? Okay, let's hold that strategy. Give me another strategy.
Line?
What if we drew a picture?
Oh.
Okay. So this is 5 inches. This is 7 inches, because I'm kind of stuck. I don't know what I'm doing. I don't have a scale, so I really can't use this right now. But let's see what else we know. The actual park is 100 yards wide. So that means that corresponds to 5, right? Oh, so now do we have some kind of corresponding going on? So 5 becomes 100. What do we multiply 5 by to get 100? Because we're really just doing a scale copy. This side is 100. So I need to know what this side is right here. So how do I get from 5 to 100? What's my multiplier? Ignore the unit. What's the multiplier?
20.
20. Okay, can I multiply 7 by 20 to get that side?
Yes.
So this side would be 140. Do we agree? All right. Have we answered the question?
Mm,
Nope. What's the question? What is the area of the actual park? Well, we know this is 140 yards, and we know this is 100 yards.
So
How are we going to find the area?
we multiply 100 and 140.
So 100 times 140.
14,000.
14,000 yards squared. So we tried using this strategy, didn't quite work out because we didn't have a scale. So we went to drawing a picture. Did the picture help us?
Yes.
Okay, sometimes a strategy doesn't work for a problem. It's a great strategy, just didn't happen to work for that problem. So we have to move on to another strategy. That's okay. Questions you have for me? All right, so everybody should get a 100 on that review, right? And I
Yeah.
should see good work tomorrow on the test. All right. So you should be done with today's assignment. How about that? We did it together. Did you like doing it together, even though we were on for longer than we usually are?
Yeah, it was fun.
Okay, I have a question for you. What if you did the activities for the next unit? What if you did the activities with the video? I'll still make the video, and you do that before you come to class, and then on Zoom class we do the practice problems together. Would you like that? Do you think that would help you learn better?
Yes,
Yes.
it would.
Would it help you learn better? Okay,
Yeah.
but the deal is you have to come to class having already done the activities. All right, and that the videos for the activities take about 20 minutes, maybe 25 minutes. So before you come to class, you have to have watched the video and done the activities. That's the only way it's going to work, okay? I will be happy to try it that way if you think that would help you learn better. Do we want to give it a try for Unit 2?
Yeah.
Okay. All right. Questions?
Yeah. So I put all my answers in the thing, the survey thing, and for the last one I put 14,000 and I got it wrong.
Let me go in and check the key. 14,000 is right. Did you put the comma in?
No.
That's why.
So am I going to get that wrong?
You can do it again.
I can?
Yeah. You can resubmit.
What was it?
Thank you.
14,000. Don't forget the comma because otherwise it's not written correctly.
Okay.
All right. Now, if all you did was just write down the answers and you didn't write down any work, that doesn't help you a whole lot. I hope you wrote down the work. Okay. All right. I will see you tomorrow to take the test. Have a great day.
I have a question.
Yes, Michael.
So for the Google form, it
Yeah.
said I submitted it, and then when I go back, like in Canvas, the submit button.
Uh-huh.
Do I still submit it on Canvas too?
No, what does it say to do? Read the directions. What does it say on Canvas? What are the directions on the activity in Canvas?
It says you'll receive a certificate in your email. Take a picture of it, of your certificate, and submit it here.
So do you understand what you're doing?
Yes.
Okay, awesome.
Okay, bye.
Bye. Oh my goodness.
So, Miss Laird, about what she said about the practice problem things.
Uh-huh.
So before we go into class in the morning, we have to do the practice problems before. So
No, you're going to do the activities.
the activities.
Yeah, the video where
Oh,
I do the lesson activities, the video that I make.
for notes and stuff.
Uh-huh, for the notes.
Oh,
Okay, so you'll do that before you come to class. And once we get started, what will happen is on Monday, we'll do Unit 2, Lesson 2 practice problems in class during Zoom. And then your asynchronous time will be watching the video for Lesson 3.
okay.
Okay, but you'll have to do Lesson 2 beforehand. So starting with the first one, you're going to have to watch something over the weekend.
Okay.
Okay, and I'll try to get that video done today or tomorrow, and it'll be up tomorrow afternoon. Okay,
Okay.
all right. Any other questions? All right, you can zoom out and get to work on anything you're missing. Make sure you get your progress report form done so that you can get 100 on a quiz.
Bye. Have a nice day.
You too. All right, I'm going to close out the meeting. See you all tomorrow.